Right. Yeah, we're live. So, and get sound. Right. One of my one of my lectures was cancelled, so I was able to be back early to give you 1 hour of last minute paper one streaming. So, there's a couple of things I want to talk about. First is oh yeah, I gotta kind of go over the exponents because there was a very good comment to the video, and then I want to redo, basically go over the code like I did in the first and still the most watched video. So it will kind of bookend it because now I've worked on this, as long as you have, I suppose, right? Like I can't remember when I posted the first one, whenever I got the code, but yeah, and I was a bit like winging it because I didn't see the code, but now we'll see how, having spent so long with the code, you could just kind of like, yeah, do this thing. So first though, let's talk about uh, predictions for section A. Probably some OOP. There's a couple of tables in the EAD that looks like there's going to be a trace. It might be a trace of the Dijkstra, like along with an adjacency matrix like in 2018 one, but you know, revise everything is the rule, or the recommendation at any rate. Right, yeah, a point about the brackets. So in this, no, this is my work music. Yeah, in the, no, it's not, yeah, that will do. In the exponent video, a viewer has reported a mistake, and it is that exponents need to are associative the other way than what you'd expect. They're not, yeah, they're, stuff, all right. So it was in, I can't remember where they put the spaces, difficulty levels, bonus score, move target back. We don't do exponents. We must have been doing it on the live streams. All right, okay. Let me just sift through the comments and I'll pull it up in a second. Right, 1 sec. Yeah. Okay, let me just go. I mean, I'll pull this up for. The problem with the exponents, which were zigzag, so that was like, okay, we don't need the right. And my coding tasks, check them here. All right. There's a section C table question. I hadn't seen it. I wasn't aware of that. I've not seen the EAD. I mean, there's like zigzags gives you an EAD to do their stuff, but it's their questions. But what I know about the EAD is the distribution of marks, which is like made public in the Wikibooks thing. So indices, not exponents in this country, like weird reasons that. Yeah, 14. Right. All right. So my zigzag, my Z, there was just a Z, not a ZZ. Yeah, there's a Z. That was done live then. So in that one, we did this. Let's go compare, select, go compare. Compare selected. And is the diff bit big? Yeah, all right, here we go. So we had the exponents here, fair enough to support it. We also need to have it in here, like at the point where we detect the exponents when evaluating, and we evaluate the regular way. The problem we have, and now let me just pull up the comment, because I think that's the best way to actually tell you. Yes, okay, so actually it isn't on the video. Yeah, I don't know why I was, didn't pull it up earlier. It missed it. Right, so accept exponents or indices, your caret. No, yeah, we're good. Oh, there's a cat over there. Bathrobe, stylish. Right. That's a very, very good thing, right? So normally we keep, this is why we, right, if you remember the thing we did on Sunday, which was in the task, the theory questions, there was one, not the mark scheme, non-right on. There was a question about, it's about the precedence. Yes, operators of equal precedence. You have to handle operators of equal precedence as if the thing you had on the stack had a higher precedence, so you need to kind of go and pop, pop it out of the stack and go into the final kind of, RPN expression. Because in RPN, your operators will appear in the order you execute, so therefore that's the order of precedence. So you want to treat a same precedence operator, like a plus and a minus, or maybe a plus, say, let's say plus and minus. You want to treat them as if, yes, as if they were, as if, yeah, you want to kind of, so that the one you get on the stack comes into the final expression first, into the RPN expression first, because it's the one we read first in the infix expression. So normally, when you read something like this, that's the point that's being made here. Like, if this were pluses, you would read this as 2 plus 3 plus 2. But in that, you would execute the operations in that order. But exponentiation, that's right, associates right to left. So 2 to the power of 3 to the power of 2, it's 2 to the power of 3 to the power of 2. So that is, oh no, that's 9. And 2 to the power of 9 is, that's like the 9th bit, right? So that's 512. Whereas this would be kind of 8 power 2, that's 64. So quite a large difference, and you want to get it right. I wish I could demo it, but I don't know if the training game is gonna let me, because I don't know if we get the numbers for it. Like with the tasks that are more likely to come up, you get some small ones that could be like a simple, like quit the game, or accept spaces. I think indices, now that I'm thinking about it, yeah, it might be the 8 if there's an 8, because like there's this order of association that matters. But let's fire it up and see if we can have it. And then the big ones, who knows, right? The oop undo with a stack, that's a possibility. I don't think it's going to be the brackets. It could be something like accept them straight in RPN, or maybe accept them in just PN in prefix notation. So I did a stream where I kind of accept all three. Let's play the training game and see what numbers we have. So 242, that should be 64, but I can't really do anything with this. So I'm gonna quickly change those. If I look for 512, right? I'm gonna want to have, like, say, a 4. So 2 to the power 3 to the power 2. So I'm going to do this plus 4 because it's 68, right? Yeah, we can use this one. Cool. Where's my 4? Oh, I need to save it, of course. Right. 2 to the power of 3 to the power of 2 plus 4. This has code the 68, but in fact it shouldn't, because as we've established, this is 512. What it should capture, in fact, you could do, you could capture it by doing 512 divide 8, which I'm pretty sure is 64, right? And then plus 4. So that's good, because this gives us a test both ways. I don't know if this is what they have in mind. So like I don't know if you can build a test for the, because I've changed it so you could test it both ways. And actually with the 4, we're going to be able to test it both ways. So it has accepted this when it shouldn't have. But this, if I kind of reset it, was if it read it correctly, 2 to the 3 power 2, that's 512, divide 8, plus 4. And that should have captured a 68. So those are going to be your test cases. Now, I've had to replace the 512 by a 4 to be able to do that plus 4. But Myren, I think at this stage in the game, I don't think there's anything you can do tonight with Zigzag that could make any significant improvement, but maybe just kind of do one so that like you get to familiarize yourself with the code hands-on, but like there's no point in doing more. Like maybe this one. Why not? Okay, back to this. I've had to replace the 512 by a 4 to make it testable, but if I hadn't, if there is an expression where, you know, you can use the numbers that are there to test this kind of two association thing, that would be a good sign that exponents would be on the test, right? The fact that there's a 3-digit number with the 512 worries me that you may need to do something with get number for user input or anywhere else that, well, certainly I think you're going to need to be able to convert from a string to a, you know, to a list of numbers and not mess this up. And so they need a number of more than 1 digit, so it doesn't do it kind of just like that. What discovering do you believe it most likely to come up as a question? What do you mean what discovering? Okay, so back to this. The problem we have here is in this very one, right? So if we still have some operators, that's the operators word stack, the stack will store the operators, and the top of the stack, the precedence of the top of the stack is larger than the precedence of the current operator, then we need to pop it out. But if it's equal, because we respect the order, we need to pop it out. So what we need to do is this, and you don't do this if this one, not the one you encounter, right? Because we could have like 2 to the power this plus that should still associate, I think so, I don't know. No, maybe not. So with the one we, if they're both, I think they need to both be exponents or indeed, you know, carets. Let me just see. They have precedence over everything else, so they will always evaluate. So it doesn't really matter about association. Association only matters if they're both like that. So, and we're gonna make a long line, right? But then what we want is operators at -1. That's the last element, the one we've just pushed on top of the stack, or appended in Python. We can do this in we can do this like this, right? You test equality in a line. This is equal to this is equal to this, and that should protect me. So now if I run it and I do my 2 power 3 power 2 plus 4, it still catches it. So what have we learned? Oh, no, and not that. Obviously, it's not that, right? We don't want to do to treat it as, you know, higher precedence and pop it to the output, the RPN output. So it's not all of this jazz. Okay, let's run it again and see if it salutes. Y 2 power 3 power 2 plus 4 minus 1, right? But 2 power 3 power 2. Now we know this is 512. Divide 8 plus 4 catches it, right? So I wish I'd done a diff of the diff, but the key thing is, yes, in here you need to handle this correctly. But that would be like 1 mark. Although if they're vicious, that might make you fail the test, and that might be 2 marks. So yeah, this was a very good point, which I hope is true, because I just took it at face value. I don't really remember the kind of like precedents particularly, but if it's that way, I'm willing to. This is how you would handle it, putting in the conditional. Right, 45 minutes left on the hour. Let's have a look at original.py, and now let me make my annotated. Actually, do you have a annotated? Yeah, let's delete this guy. And like let's re-annotate it. Okay, any of you that think they're absolutely done for the programming like BNC, I really suggest you have a look at my video on the mark schemes, because there's just very basics you can do that allow you to scrape, you know, yeah, a fair few marks in the grand scheme of, you know, rather than kind of blanking it all together. So, I've copied it, I want to paste it and rename it. So, for each of the functions, we are gonna just say what they do. So this literally, you know, called, yeah, by the, you know, if underscore main, so like main program, you know, kind of basically the main program. So I would say max target, max number, those are config variables, and, you know, defines the variables, right? And then it runs, returns nothing, right? It's not really a function. And then we'll call create targets, fill number, and play game. So this is why this is the tree that they had on the, well, I had the theory questions, right? In this, play game will call, sorry, play game is called by main, so we don't even see that, right? But if you get the hierarchy above, play game is where the meat of the stuff is, obviously, right? But like this will call, because it needs to make some targets, needs to make some numbers, and this is where we get, you know, your numbers allowed and targets that we're going to kind of pass through functions throughout this program. So it calls whatever they called, create target, oops, fill number, and play game. Play game. So that's like the core, you know, everything runs off play game. All games have a game loop, right? There's the idea that you kind of keep doing the same thing until you, I mean, all programs have a kind of rendering loops. They're in order, right? Which video of the basics? You actually, you would use a new file. This is what I've done here, right? You've seen I've kind of using the thing. They're not going to tell you how to do it. They just want the screenshots, right? No, you paste screenshots. Like I'm surprised that you've not practiced on actual electronic answer documents. Your electronic answer document is a Word doc. And what you do is you simply paste screenshots of your code and screenshots of your test. So they have an on-computer exam that makes you code, but like have very little actual computer involved. It gets better because then those that needs to get printed out to get marked. And often to get marked, they'll actually get scanned again, sent digitally to the marker that might then again print and rescan. So like for an on-computer paper, it's like actually not paperless at all. It's very paperful. So, I mean, all right. So play game does the contain the main gain loop. It will, you know, it displays the state. checks validation, validation, then checks the numbers, and checks evaluation. Any of those score. No, they don't even score. It's like in the check it's the target, it's kind of thing. Then if that's the case, yeah. If all three, you know, we remove the targets already moved in the evaluation, but we refill targets and numbers. I think we might like remove numbers used as well, right? And then the fill numbers. Update target is going to be in the game loop as well, whatever happened, because like actually, if all three refill numbers and you refill targets, there's always, yeah, then always score -1, weirdly, which makes, yeah, -1, and then update the targets. That's it. So if you need to do something where you change, you know, that takes in the user input, so like a quit or a sort, right? Like you get a, you know, the user wants to put sort and it sorts everything, and because the -1s are negative, it basically puts all of the blank space at the front, which is helpful because then that gives you more time before you lose. No, you can't ask to add OOP on the skeleton program in section D because that's way too big of a question. We have been over this many times and in the comment. Right, I think this one is done. This is takes in RPN expression, evaluates it, goes over target list. If it matches, removes it, and scores +2. Boom. All of those will take in the function and return them, but in practice they don't really need to return them because they get changed into place. In fact, here it doesn't return them where, you know, ultimately it does a change in place where there's plenty of places where it kind of passes and returns it again. Doesn't really matter. This will remove the numbers that are used. So for this, we kind of convert again in RPN. The input is infix as a string. Go over it to find numbers from available numbers. Yeah. If int item isn't, remove, they'll move the first one, but if you encounter it again, then they will end up removing the second one. This remove does it in place. So there's that. Update targets is just, that's the classic update. The target carousel gallery to the left. Duplicate the last number in normal mode. Refill with a random valid number. So this will call get target. Yeah, I should put the call. So I'm not very being very diligent. Oh, the calls, you can see the calls there, right? Like I think this is more about what it does. This is update targets, check numbers, use that one, numbers allowed. It literally checks, I mean, it's kind of in the name, isn't it? Checks if numbers used are all in numbers allowed. So it makes a copy. To check no number is used twice. That's important because that's not in the title, right? You can only use, so that's why we get two twos in the Yeah, we've got 2 2s in the test one, but like this will remove, right? Kind of you build a temp on this, which is a bit of a annoying way, right? You could call a list and do a clone, but that makes the code consistent with the other languages. This is where you have, I see a colleague that does the C# version, and oh boy, removes them. That's why it checks they're here and only used once. Then check valid number. This is the thing. So it checks it's a number, so like 1 or more digits with a regex, which again, they are native function for this, and then also checks it's strictly positive and more equal to max number. Display state just literally displays the state, so like calls 3 subfunctions, to display targets numbers allowed. Display subfunctions, and display score displays the score in 2 blank lines. So they put the display stuff in the middle. I guess it might be relevant. I don't even know, but like the order doesn't make sense. I feel in this piece of code, and it's in displays. In the in the most roundabout way, right? And then the targets. Okay, this has a little bit fancier because with pipes, as in this, in between. -1 means blank. Isn't choice converted to uppercase? Oh no, we converted to lowercase because that way if I type an uppercase Y, it still gets accepted. That was in the stream last Sunday. Convert to RPN, converts to RPN. So this uses the stack. Yeah, if there's a table in the EAD for section C, it's entirely possible you might get kind of asked to do a stack, basically do this by hand. String to RPN. So that's a list of ints or operands and str operators. It does the thing with the precedence, and this is the kind of RPN conversion that we've got videos about. There's some traces, kind of would look like this, but this is better. Right, you use a stack to hello. Well, you put the operators on the stack, you pop them, and then it comes at the other end, right? This is your classic thing. So if you've got a table in your EAD for section C, it's entirely possible it could be something like this. Geeks to Geeks has a good explanation. It's kind of converting to an infix to an RPN. This evaluates the RPN expression. Is there anything fancy here? Yeah, this will break. Will break. Will break on divide by 0. I mean, it's like the meme, right? You all know kind of the divide by 0 meme. Oh, look. Yeah, plenty. There it is. Yeah, I can kill that. I've never actually played the game. I don't know what my high score is. I found it actually quite frustrating. Although maybe playing with the solver, those are always very good. This is of a dam when sometimes they need to kind of pull the plug on it, right? So that will break on divide by 0. Will return -1 if the result is not an integer. That's important. This is what we do here as well in the more, I mean, we import the whole math module for this is, well, that's how it's done. Because again, gotta be consistent with the other languages. I think they do it in Delphi as well. This is just more. That gets number for user input. Oh, so this is, read the user input string. Returns the full number and the new position +1. I think like, and the position of its end of the number +1. That's the weird thing with the thing, because that's why we have to do a -1 in the convert to RPN. All right, this kind of all, yeah, don't know why it goes. I think what it does is like it takes you to the next. It takes you to returns the position of the next number, assuming max 1 character of separation. So it weirdly skips it because it's the way it's structured, right? Because this position +=1 will always be there even after that, right? When it really should be here, inside this. But then you'd have to like change the -1 there, and so we kind of keep on reading. It's a while loop with more digits, and we kind of click the position along. We return the new position, and this here. So you get this problem when you were sent to an empty. Sent. If it was given a position, that's not the start. It's not the end of the number. Boom. Right, so this is the another regex use, checks if the user input is a valid infix, no brackets, no spaces, expression with a regex. It uses, so that means 1 digit, right? Any number between 0 and 9 plus means 1 and more time. Then, then those are everything needs to be escaped, which is kind of slightly annoying, but like, plus or minus, or because there's a special character in regular expressions, you need to escape them once and then you double escape it, but like plus or minus or star or slash, and then this itself is repeated, right? That's the brackets here, it's repeated one or more times, and then you get a final number, which is like a digit 1 or more time. For operators, and then this, then a number which is digit 1 or more times. Yeah, cool. Anything else? Failed. Returns false. Returns a boolean. This gets a target that is between 1 and max target. Inclusive. Gets a number, right? 1 and max number. This is used once for the initial creation of targets, of the targets list, right? Called once in main or play game? In main, right? In main. So we call it here, otherwise we just kind of hard code the targets in training mode. Called once in main, only in regular mode. Puts, makes the first 5 slots empty, -1, populates the rest with get target. This is pretty cool. This is when we need to pass it the training mode flag. It's fill numbers. Again, that's also called this is called every time, and like, well, every time we have a reason to fill the numbers, fills available numbers. In training mode, always the same 5. In normal mode, we make up the numbers allowed to 5 elements with random numbers returned by get number, right? Make number, get number, get number. Right. It's called once to initialize in main. In play game will be called after the operands used have been removed from available numbers. All right, name, yeah, and that's it. So save this, and ooh, not all of them. Oh no, I don't want this. I don't want this. Is bad. Push it, stage it, commit and I don't, no, I just want to, yeah, comment it. We're not doing, yeah. Annotated skeleton code. After, so how long was I, annotated skeleton code, yeah. So you can all enjoy it, name it, and do I need to kind of close that? And this is retro, and so now, excellent, that's been, and then I want to push it up. Which means that if I now go on my GitHub, I'm going to put the link in the video description, as they say. You can enjoy this code commented. I might as well push all of the rest. I mean, I've got everything, put all of that stuff in, and yeah. Yeah, there you go. I take you straight to the link and the final. I'm putting it. Gonna put in the chat, and I'm gonna put in the video description, which I can change live. Okay, how do I do a? I thought I could do a poll or something. Yeah, you okay with me? I wanted to do kind of like see. Oh yeah, let's start the poll. All right. What should I do for next up? So we can have next up, like what does paper 2, right? Like maybe a Dijkstra trace. because we all love Dijkstra, and it looks like it might be from DED. What we could do is a section B. We could do a section D, sort command from the player, and must contain between 1 and 35 characters. Yeah, okay, I've got too many. Sort command. And what else can we do? What else have I got? What's on section C? We've done A. There's graph trees. Stack conversion. Could do a trace of the... Nah, I can't be bothered doing a trace. I think that's going to be it. That's the poll. We get 3 options. Start poll. Am I starting the option? Yeah, starting the poll. And results will be coming in any minute as we have still everything to play. Oh wow, okay, yeah, no, oh, Dijkstra was coming up very hot. I should... Dijkstra is 50, ooh. Ah, now we have a tie between section B and Dijkstra. Dijkstra is up in the lead again. I mean, you have both of those, right? Both of those are in the stream from like 2 weeks ago. I'm sorry they're not all tagged and chaptered, but like if you go back through the Sunday live stream, I've done like 2 section Bs and then a Dijkstra trace. Okay, I think it's going to be the Dijkstra trace. Fair enough. I have no imagination, so... No, I have some imagination. Do I have some imagination? Because... Hold on. Ooh, I don't have a network X. Okay, so I can't make my own graph on this machine. I mean, I could pip install, but like, yeah, it's a long story. Whatever. Okay, so this, I believe it was in... Sorry, I need to switch to this. I believe it was in the 2018 paper, right? In all its glory. Okay, so I might kind of like copy and paste it and then empty it. Oh, I can't do it from here, sorry. Yeah. Copy, paste, and then edit CSV and wipe it. Nice little... Okay, so they start us with some stuff, but they're not kind of, they're not like absolute bastards. They do give us the... No, I went too far. I went way too far. Oh, hello. Yeah. Okay, so we start with the first 2, and then the column V is all populated, UQV are populated, and then first 2 rows, obviously first row, like those are the headers, and then the 0, this lonely 0 here, right? So this means that every V is populated as well. That's like way too easy. Come on. I mean, they're giving the whole thing away. All right, so we have, let me put them side by side. I want, oh, now this is, well, does this scale? Not, okay. We want to have a look at the algorithm, which is this. Okay. And then we also want to have a look at the graph, which is like above. Yeah, this is going to be a nightmare of flicking back and forth, isn't it? How can I solve this problem? I can't. I will scroll back and forth like some kind of caveman. Right, we start here. Let's do it from the top, right? Like Q is initialized as an empty Q initially, and then for C, like C1, okay, sure. Why C1? Don't know, going from 1 to 6. We initialize the D array, so I've got like all of them from D1 to, I'm like, here. Right, all of the... Oh, that's what I had done last time. Oh no, I kind of like go and take the whole thing and make everything like a tiny bit smaller. I am not liking this at all. Yeah, that's better. Okay, and then a bit more here. Oh my god, what? No. Okay, well, at least now we can concertinate up. Do you know what? I'm gonna, like, look at it as a simple CSV file. I should be able to kind of sort it out. Have I worked this correctly? Yeah, because they give you all of this, and this is the big list and so on, right? Let's have a look at this one. I'll switch back and forth. It's fine. Right, so it's putting 20 into the distance for, it's initializing all of them to 20. That's like an arbitrarily large number. Like the point is you would go potentially larger than this because the sum of, they're all kind of one digit, but if you do a long route, you could get 20. So this is like, this is meant to be like a million, a gazillion, so large, it's like if there's a path between the nodes, then it will be cheaper than this one. And then P, which are the previous nodes, well, you guys don't know this, right? If you see this question, you don't know that it's out. And then you would recognize a Dijkstra, right? Because it does say it's Dijkstra. P, that's for the previous node, because this gives you the shortest path, but like you need to know how to get there. So by building back up the previous nodes that you got there, you get from your starting thing to the quickest path to, each of those. Now, we start from every Dijkstra algorithm needs a starting point. So for us, it's the first node, and which means that the distance to this node is evidently 0, right? And as long as the queue is not empty, we do, okay, so let me take all of the columns. It's just some days it's not even worth it. Thank you. Except this one. But then no. Click elsewhere. Except this column, because that's going to have the queue that I want to have a look at this one. And I messed it up again, did I? Yeah, I did like, okay, so this was here. I know that this is the, I think I've accidentally swapped this. This needs to be here, because clearly it's a 5 and a 6. What? Man, I'm gonna spend, all right, so I'm giving myself like an extra bit of time. I think I can make it 20 minutes. I get something at 6:30. I'm really sorry. I'm just like, this happened the last time as well. It's the dumb, like, CSV viewer, because it's fine. It's a nice little module to get your CSVs in Visual Studio, but then once you get the PDF like plugin on the side, and I'm streaming with OBS and whatever, it's like it's choking a little bit on the load. This is a 10-year-old MacBook Pro. I actually bought a new computer. I got myself a very nifty little foldy Lenovo, which I'm very happy with. Well, so far, Windows 11, so mileage varies. Fine, Dijkstra Express copy. This one's the right order. Let's edit the CSV. Bloody hell. Okay, I'm not giving up. I will narrow those columns. Cool. Super. And then just this one a little bit larger. Well, fine. Okay, we're good. Which means that I can now have this fully to this side. And now I'm seeing them more. Right, so we initialize 20s everywhere and then -1s everywhere as well. And I need to delete, I think, just this. Like, kind of shameful, but we've got D1 equals 0. Whilst the queue is not empty, U is the next node, right? So we pop in 1, U becomes that. You notice Q starts at 2. V. Now U is the current node we're exploring, right? And V is like which ones of the neighbors are we looking at, and then we're kind of looking at paths and whether they change. So we put U becomes equal to the next node from Q. We remove U from the queue. That's kind of the point of the queue, right? For each V in Q, so for the remainders in the queue that have not been explored yet, we are going to where they are connected. So adjacency matrix is larger than 0. By the way, this, if you read the whole question, that should have clued you as to why actually if there's no path, you should put a 0 in. I still disagree personally, but then whatever. Fair enough. That's kind of like the way to do it. Although you could type it I mean, your adjacency matrix is meant to be a 2D array, so you're not going to be able to mix and match, so that's kind of fair enough. Anyway, 0 means no path, so this means for all of the neighbors where there's a path, then A becomes equal to the distance to U that we have so far, which is 0, right? Because in this instance, we're starting path, plus whatever's in the adjacency matrix when U and V. So let's do this, right? So the first V is 2. So this means that this we're putting there, this is smaller than 20, right? So we kind of like sum the 0 to the 2 we have, the 2 we have in the adjacency matrix. This is smaller than what we currently have in D2, so it gets replaced. This is 2. Then we go to the next neighbor, to the next, kind of next element, this, which happens to be a neighbor because it's 3 and there is a route to 3 and it costs 5. So there's a 5 that goes in here. Then the next neighbor is a 4, there is a route to 4, so 3 goes in here, again because we're just summing with 0, so far our path from a starting node is, obviously cost is 0, and then finally only 6, because remember we're filtering them out because there's no path to 5, so we skip this one, right, and at this one we go here, and that's an 8 to go to 6. And do we also populate the D as well? The P, yes, and if we find a shorter path, then we say, all right, for the previous one should have U, should have the current thing. So because each time we found a shorter one, P2 has got U meaning 1, right? P3 is going to have 1, P4 is going to have 1, and P6 is going to have 1. I don't have a P5, which is slightly problematic. Add column, like here, insert column, right? Yeah, do you have a right? P5 has got nothing, so fine. P5 says -1, so that's convenient. Cool. So we've done this, we've done the 8 as well. P6, have I got like my P1 and P6? Yeah, which is massive for some reason. And yeah, right. So now we popped 2. So we're back here. We finished this loop, we've done all of these ifs, so we finished that loop, we finished this N4, and then we are back here. The Q is still not empty, 2 goes into U. And then we start again at neighbors. So 2 to 3. There is a route to 2 to 3, that's why we've kind of selected it as V. It is 1. The current route we have from, so 1 plus 2, because that's the shortest route that we know of for 2, and we've explored 2, because it's now here, right, is 2. So 2 plus 1 is 3, which is smaller than 5, so that's a shorter path, which means that the D3 gets updated with a 3, the P3 gets updated with a 2. So to get the shortest path to 3 from 1, you have to come from 2, which this information is enough to reconstitute the full path, because like you know that from 2, the shortest path comes straight from 1. Now, then they have no connections, there's no cheaper connection than 0 to 0, right? Obviously, you can't do 2 plus 2 is kind of, you started in 1, right? So the shorter path to 1 is to stay there. So that means that, 3 is the only one that's connected to 2 in a meaningful way that's gonna change this. That's why this only one goes into V, and then we go straight to looking at 3. So 3 goes into U, and then we look at the neighbors of 3. So to 1, obviously nothing's gonna beat 0, so that skips that. We're looking at, for some reason, we're looking straight at 6. To 2, it's like 3, whatever we get at the moment, we get 3. 3 plus 1 is 4. We only know to get there with 2, so we're not gonna use this. 6, so now in 3, I have 3. 3 plus 6 is 9, which is, no, 3 plus 4, sorry, 3 plus 4 is 7. Sorry, yeah, that's the thing. 3 plus 4 is 7, which is cheaper, which is kind of like shorter than what I have currently as the shortest path to 6, which was currently 8, straight from 1. So here again, this gets updated, and the shortest preceding node to get to 6 in the shortest path is now 3. We're done with 3, now 4 moves there. Again, 1, you can't beat it, you're fine. 5 is the one that goes into V, because that's the only one that connected. The path to 4 was 3. We got that straight coming from 4. We don't have an existing path to 5, right? So it's going to beat the 20. So we know that it's going to 3 plus 1, and that becomes 3 plus 1, 4. And then in P5, the previous node that you need to come from to get the shortest path in that. And then we go to 5 for U. There's only one remaining here, and we have a route to it, and it's 6. 5 and 6 is 5. So currently the path I have to get to 6, the shortest path is 7. And it cost me, what have I done? this was meant, sorry, this is meant to be here, right? I am now in 5, so I've came here at the shortest path of 4, and to get to 6, I could add 5 to it, so that would give me a 9, but at the moment I've got a path in 7, so I'm not going to change this, it doesn't win it. And then in 6, there's no more neighbors in there, so so there's nothing to check. And so by the time you have this, which like the final values are 0, 2, 3, also 3 to 4, yeah, 4 to get to 5, and 7 to get to 6, with the neighboring ones nothing, because you start from where you are, right? Or -1, I guess, because that was your starting one. 1, 2, to get to 3, the shortest path you go via 2, rather than take the expensive one via 5. P4, you come straight from 1, and P5, you come from 4, and P6, you come from 3. Which means that this tells you, right, this is enough to kind of reconstitute the shortest path to any of those targets by kind of going to look in the corresponding column. So you don't need to store the full path to the node, just the previous one. You can't validate the parity of brackets with regular expressions. You have to kind of, but like they will tell you, assume sane input generally in those questions. All right. If you want to put up if you want to repaste your questions, then I'm finally looking at the chats. Validating postfix. Remember, validating postfix will come to you in a with delimiters, right? You have to, if you're called to accept postfix expression, you need delimiters, because you're not going to distinguish between the number 25 and like a 2 and a 5. Exponents, the scoring bug might be there, which, yeah, because there's a way of capturing this. You have to look at the I want to have a look at the let me run this and see what goes on there. I think there's a lot to be gained from looking at the training game and what that implies, but I think, yeah, all right, yes, to play the training game. Yeah, there's stuff we can get twice, right? Because like, what appears twice? 23. 8 times 4 plus 4, 23. 8 times 23. 8 times 3, 24. Oh, 8 times 3 minus... It's not going to do, yeah, it doesn't do brackets, so that's not going to work, right? Because it's like current score 5. Well, I'll be damned. Oh yeah, it doesn't do brackets, but it does precedence, so that works. Okay, so I would say, because there's definitely something, the 119 as well would be good to catch, because then you wouldn't have like those, you could actually clear the full board and actually win. Because at the moment you can't really win in this game, you can just like try and do the best here before you lose. Yeah, Oliver, that's absolutely right. The training game is literally there so you get something to test, which means that the way, what you've got in the training game tells you what kind of tests they are. It's not innocent, you get a large number both here and here, although it's more important here than in here, to be sure. It's not innocent that you get stuff that appears several times. Even before we started duplicating the end, that would appear there. So, like, because that has given me 5, which is kind of weird, because I should have gotten just... I should have gotten me 3, right? More than 5. Did I fix the bug in the original? What's happened? That's not right. Score +2 every time I score a thing, and then there's always the -1 row. I hope this is the actual original. I think I have this. Okay. Yeah, okay, that's the... Oh, no. Oh no! So I annotated briefly the original AQA one. So I don't understand. We got in 5. Oh, is there a 23 at the front? Is that what I missed? Yes. Okay. So we cleared 3 23s. That's why. But of course we're gonna find 3. So this 119, right? It's like 127, which is, so that's like 512 divided 2. I can't do 2 plus 2. Can do 2 times 2. But will this be... That's not going to work, but like in theory, I did that and then minus 8. Yeah. See the exponent, which was like Z14, right, I guess? Let's do the exponents again, because I think that like, I've got like 5 minutes. I can do 5 minutes. Like, let's just do the exponents again, because I think this could be a test case for the exponents. Because 119, like, you know, they can verify that you get them all, as it were, because you're bound to have a lot, because it's at the back. There was 2119 when we started the training game. Yeah, I'm feeling hot. Let's do this. And this is again, but super important, right? So just to say, right? So if we want to accept the indices, what do we need to do? First up, let's have a look, find, say, the star, right? Because star is not going to, well, obviously not as a regex. If you find your star, you're going to find all of the places where the operators appear. Remember your training. The reason you're doing this is you can do this super fast on the day, because it's as much time saved. We're in the precedence one, so make it big. You don't have to. I'm going multiply by 2 rather than there could have been 6, rather than 8. We still don't know. Here again, put your caret. I think whilst we're here, we're also going to put another elif to evaluate it, right? So if it is the caret, we are going to, the result is going to become equal to num1 multiply star in Python, right? Num2. Unfortunately, they've got a lot of stars right here as well. So we need to do literal with 2 backslashes, which are here on my Mac keyboard, and then the caret, because the caret means the start of a regular expression, so it's a reserved keyword, so you need to escape it once, but then because then you need to escape this, so it's complicated. You had to be there. That's another one. All right, so I've captured all of the places where they are, and literally because I've done this, I'm fine, except I just need to get the precedence sorted out. Which is the thing we did at the very beginning, right? If they're equal, we're gonna, pop it out and pop so that the RPN output of this conversion function has them in the right order. They're evaluated in the order we've read them in the infix expression, except when both the operator that's at the top of the stack, so operators -1, which should be equal to the current operator. What happened to complete, man? Well, if that's equal to a caret, then you don't, right? So that then you do the thing, and then that's it, right? So you've done the. Okay, so maybe I don't get things right the first time, but I'm pretty sure that's only because you actually have them in one word, as it were. I think exponents could be the 7 marker. Now that I know that it's got the association thing, so many thanks. I need to shout him out. I'm assuming it's a him, like statistically. One of the viewers that spotted it. Okay, so now that I've got exponentiation, I can do 512 divided by 8 multiplied by 2. Where am I going with this? That's 128 minus 2 to the power of 3. Yeah, 2 to the power of 3 is 8. Yeah, we're all in agreement. And that's not that, because I can't do my. That's interesting. Let me mess up here. Okay, there's one I can test. Surely there's like 2 power 3, no, 2, there was one, yeah, there was one which was 2, well, this was the one we're doing, right? Like 2 power 3 power 2, So if I've done this right, this is 512, which I had again. Well, I can't test the 512 then. I'll get an 8. Oh, right. And then I can say, you know, divide plus 8. This is like the roundabout. Yeah, okay, I had a space. It doesn't count, I had a space. Oh, come on, all right. I have to say my negative high score is quite large at this game. Okay, divide that by 512 and then add 8 to this, and I want to get the 9. I got the 9, yay! Okay, so the 23 is getting dangerously close, perilously close. So that was, we've established that 23 was 8 times 2 times 2. How did I clear it? Bad at this. Okay, let's just, so that shows that we're doing the things right, and we do, you know, thing. If I do 8 power 2 plus, no, because I can only do 4. All right. 8 power 3. No, that's 64 times 8, that's way too large. But like, there's a way of doing like 128. How do I get to 128 from this? Like 512 divide 4. Oh, all right, so how about, well, actually, yeah, 512. I mean, you don't even need to put the exponent into, oh, and it's time, right? Divide 2. Then divide 2 again, and then like minus 8. And that wasn't the 119, that's annoying. Oh, well, I don't know, I don't know how to play the game anyway. Right, so I feel like this was the end of the very surprising, unexpected stream. I hope you were as delighted to watch it as I was. Break a leg tomorrow. Remember, like, it's all in the kind of like mental game, like don't panic, get the marks you can, because there's plenty that you know, are just you're gonna freeze because you're panicking. Attempt every question, because you never know, but like don't sink too much into any particular one. And no, it doesn't matter, the exponent precedence just need to be larger than 4. Yeah, for intuitive, positive mindset, yo. Yeah, enjoy the show. I might do like a assembly. That's the only thing on paper 2 I want to be bothered about. Although I do like the BNFs, but I want to do an assembly twice. I've put an assembly, a paper 2 question video up. Yeah, break a leg tomorrow, and then yeah, I might see you Sunday for a paper 2 stream if I can be bothered. Love you, take care. Woo!